Let's talk about verifying fundamental trigonometric identities. So first we're going to go through several of them. The Pythagorean identities, sine squared theta plus cosine squared theta is 1. We already knew about that one. And then if you take and divide, sine squared theta plus cosine squared theta equals 1, and divide everything by sine squared theta, you get this one up here, 1 plus cotangent squared theta equals cosecant squared theta. And then if you take sine squared theta plus cosine squared theta equals 1 and divide everything by cosine squared theta, you get 1 plus tangent squared theta equals secant squared theta. Okay, so those are some really helpful identities that relate these different trigonometric functions. Then we have even odd identities. Tangent negative theta is the negative of tangent theta. Cotangent negative theta is negative cotangent theta. Sine of negative theta is negative sine of theta. Cosecant negative theta is negative cosecant theta. So these are all odd. And then cosine negative theta equals cosine theta, secant negative theta is secant theta. These are even. So remember that odd are symmetrical with respect to the origin, even are symmetrical with respect to the y-axis. Then we have these reciprocal identities. By the way, I would start writing this down on paper, physically writing this down, making a list of these to help you remember them. It's not going to do you a lot of good if you're on the test looking for where is this written on the piece of paper. It's really good to know these. Sine theta is 1 over cosecant theta. Cosine theta is 1 over secant theta. Tangent theta is 1 over cotangent theta. Cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tangent theta. Then we have our quotient identities. You probably already know this. Tangent theta is sine over cosine. Cotangent theta is cosine theta over sine theta. So for our first example, this is graph both sides of the identity. Cotangent theta is 1 over tangent theta that we just saw right up here. And so graph y equals cotangent theta and y equals tangent of 1 over tangent theta. So I'm just thinking the cotangent theta, if we were to graph that, we know we have, so cotangent, let me write this, y equals, that's going to be cosine theta over sine theta. So where's sine going to be 0? Sine is going to be 0 at pi, negative pi, and 0. So we're going to have vertical asymptotes at negative pi, at 2 pi, at 0, at pi, and then at 2 pi. And so also for our cotangent theta, if we want to take some values, we know that pi over 2 is going to be a 0. And these will just repeat, so I'll just work on this one segment, and then we can repeat them. And this would be pi over 4. This would be 3 pi over 4. So cosine of, well, cotangent of pi over 4 is 1. So let me scale this up. Let's go 1, 2, 3, 4. So we'll call this here. Cotangent of 3 pi over 4 is negative 1. So it's going to be coming down like so. Going across like that. And then same thing here. These are these values that we know. These kind of standard values that we would know. So when we looked at, if we were to look at tangent, let me just finish doing these while I'm talking. When we think about tangent, so the asymptotes on tangent are at pi over 2, negative pi over 2, and so on. All the ones that are going to be like an odd number times pi over 2. And so in our tangent realm, I mean, we would have had this as an asymptote and this as an asymptote. And so 0 would have been at pi, which was why 1 over 0 is now an asymptote. So it'll approach that. And our function would have looked something, in fact, let me just go negative pi over 2 to pi over 2. And I hope you can see this gray. I'm trying to be a little bit subtle about it. So we would have had, cotangent of negative pi over 4 is negative 1. Cotangent of tangent of negative pi over 4, tangent and tangent, would have given us a curve like this up. So going 1 over that, well, 1 over negative 1 is still negative 1. 1 over 0 gives us infinity, so we get that asymptote, and 1 over 1 is 1. So what I'm trying to get at is, so we see how this is getting closer to 0. 1 over that goes to negative infinity. This getting close to 0, 1 over that makes that positive infinity, which is why our graph of 1 over tangent, we would get these vertical asymptotes where tangent was 0, and then we would get as that tangent approached 0, 1 over 0 is going towards infinity, we get going up or going down. And that's where we get these curves. So I want to relate it that way, graphically relate these two. So I think we'll stop there, and I'm going to make a part 2 to this because I don't like these videos being too long, and I've got several more examples to do.